Thanks for joining us for this tech talk. We'll be talking about deploying large-scale clouds on-prem.
Considering a cloud transformation or migration? Check out the Total Guide to Private Cloud from Mirantis to learn how open source cloud on-prem gives you cloud benefits without the downsides. Download now at mirantis.com/privatecloud.
Before I go through the agenda, I'll give you a brief introduction to who'll be providing the talk. It'll be myself. I'm Satnam Johal. I work within Mirantis as a senior solution architect. I've worked in the IT industry for a good number of years now, 25 or so plus. Started out in IT support, moved up the career path, worked in senior roles in implementation, architecture, consultancy, and technical pre-sales. I've worked for large organizations in the past, all before joining Mirantis, and I've been here for coming close to 5 years now. I'll hand you over to my colleague Menno for a brief introduction as well.
Yeah, thank you, Satnam. So my name is Menno de Fouw. I'm a technical program manager, professional services in Mirantis. I have over 15 years experience in the IT industry. Have been working for companies such as Dell Technologies for 8.5 years in the large enterprise support organization for their file and block storage, and I was doing technical escalation management as well. At Mirantis, starting 5 years ago in the role as a customer success manager in the support organization, and then I moved to a technical program manager role in professional services, and both roles involve working with multiple key customers on diverse project streams for the individual customer.
I'll be covering why should you build an on-premise cloud, also talking about the sort of technology imperatives and business outcomes that can drive that. What are the technical considerations that come to mind? What should be the general design principles when building an on-premise cloud? And then I'll go into more depth into how we approach that ourselves as an organization. So I'll start to talk around what we see as what is an ideal enterprise cloud solution. What can we offer you as an infrastructure partner in that space? Key infrastructure components as we see it. And then I'll also give you a brief intro into how we approach that from a product perspective with our Mirantis OpenStack for Kubernetes piece. Following which, Menno will talk you through deployment, go on to talk about in detail the whole deployment process, what's associated with that, what a large MOSK cloud consists of, so bringing to life the whole large on-premise cloud footprint, and then also to add more color to it and bring it to a real-life use case scenario. We'll talk about a customer example and also share with you what we see as sort of challenges, pitfalls, things to overcome, deployment improvements. So we start to give you that sort of level of insight that we've gained and share that with you. Okay, right. So moving on to technology imperatives. So ultimately, the driver for this is business outcomes. So when we talk to most of the organizations that we work with, it is all about sort of outpacing competitors. And how is that done? That's through speed. So it's all about reducing access to features, functions, reducing time, innovating quicker. Also from the customer perspective, it's about meeting demands of customers, and that's provided through agility, being agile with your cloud platform, having the flexibility and performance at scale is absolutely essential. And then ultimately, as most large enterprises want, is to be able to act and operate like a service provider. Our job is to provide that through simplicity. So we want to take away the layers of complexity and also reduce that cost in owning that infrastructure. So being able to provide you that sort of resource pool on demand is absolutely essential within that. And then it's about mitigating and eliminating risk. So security is a key part of any critical system running within an enterprise. And that's also important where you look at protecting the data that you're using, looking at making sure the environment is secure, and and locked down in terms of access. And there's also components around sort of how do you build the environment to make sure you're not open to exposing any vulnerabilities. So we see that ultimately addressing these business outcomes are always underpinned by these types of technology requirements. When it comes to the actual laying out your cloud and the footprint, one of the discussions, the key areas that we start to really drill into is what is required in terms of the sort of compute power that you need. Are you getting the right equipment in terms of hardware? So are you ordering the right type of CPU for your workload? What is the ratio of RAM required against that? What are we looking at in terms of oversubscription? Are some of the discussions that we generally get involved in and share our experience and knowledge with. And then looking at the workload and thinking, well, is there any type of, say, pinning required for this particular application to confirm and sort of meet SLAs in terms of performance? And then you can, within that, look at different host profiles. And when I say that, I mean different types of hardware configurations that are applicable to certain workloads. So part of these discussions is what starts to draw out what your underlying cloud should look like from a hardware perspective. Naturally, also network comes into play. So we do support a couple of software-defined network solutions within our platform. Again, that all comes down to what is required from your workload. What are we looking at from a hardware perspective in terms of accommodating your bandwidth? How do we build in resilience, not only at the physical layer, but also at the logical tier, building in and utilizing highly available solutions as well. And then, of course, making sure that we can meet the performance requirements of your workload. Again, this is all driven through things that we can fine tune within the platform. Storage pretty much is the other part of that equation. Now, what do you require in terms of your IOPS for your workload? What's required in terms of capacity? Again, resilience. We can look at how we allocate data across your nodes, what level of replication is needed. Also, back to the performance piece. So we generally have quite in-depth conversations around what is needed to build a good, solid, and functional on-premise cloud. And then we move on to the discussions around, well, okay, what are you looking at in terms of size and scale and growth? What do we start with, what we would say is a minimal viable product? Or do we start to look with going with a larger footprint up front? Again, this comes down to workload, comes down to hardware availability. We did see during COVID, which is some time ago now, but we started to see the hardware shortages having a real impact on a lot of our large enterprise-grade customers. So that can also start to play a key part in your decision and thought process. So these are things to consider, and these are also things that, like the likes of myself in my role, I start to look at unpacking with our customers. Security is absolutely essential, as I mentioned on the previous slide. So integration with systems from a security perspective has been able to capture, say, the relevant information in terms of logs, access logs, audit logs, vulnerability management within the platform as well. How can you be certain that you aren't being exposed to vulnerabilities? It's our job to ensure that we're providing you with the correct software that can address those requirements as well. Naturally, building in hardening, running a regular vulnerability management process within our product engineering department is absolutely essential within that. So that's also plays a key part. Again, security can be broad in terms of access, who can access what, when, where, how's that logged. All of that starts to come into play as well. But this is more so just a general overview, just to say, bring to light what are the key considerations that come into play. General design principles. So standardization is very, very important when it starts to come to an on-premise cloud environment. We start to look at, like I said, the the underlying sort of configuration of the cloud, and then looking at how can we standardize this for certain types of workload. Not only is it just for a specific workload, but how can we bundle as much workload as we can to maximize utilization from a cloud perspective as well. So same types of node for the same function is something that is something that needs to be explored. Simplification as well. So avoid any type of sort of exotic or unique hardware configurations if possible. If there are scenarios where that does need to be accommodated, that can certainly be done. But that would then be applicable to, say, a subset of your cloud platform configuration. And that's also doable. Mid-range, more mid-range instead of fewer high-end nodes. Again, it's kind of back to the same point that I've made with the exotic hardware. So it's good to have mid-range in the sense of sort of lowering your entry barrier in terms of cost as well. And then following sizing recommendations. So we do document on our docs.mirantis.com website the minimum spec that we would advise for certain different types of deployment profiles. So that's also key in the sense that we can bring along our experience and be able to talk you through that and share with you what we would say is the right sizing configuration in terms of your control plane to accommodate your cloud environment as well. That right sizing essentially will help you avoid bottlenecks, not only up front, but also ongoing. That's where it's crucial to have this level of dialogue. And finally, reliability is key. That's absolutely essential. So what do we mean by that? That's us giving you guaranteed SLAs, us ensuring that the platform is designed to be highly available, highly resilient, and I'll go into sort of what underpins our configuration and our platform components as well, just to give you more insight onto that. Okay, moving on from there, just on to what the Mirantis approach is. So how do we address this all and what is our solution consist of? So let's look at what we see as what an ideal enterprise cloud consists of. Ultimately, you want it to be a smaller version of a hyperscaler, optimized for your specific needs, back to the point that I made around ensuring that we understand what is required of the platform to make sure that we then are not only just getting the right sort of bill of materials, but we're also making sure that we're optimizing it from a configuration perspective to address your requirements. Agnostic of the underlying hardware layers, so you can use your hardware vendor of choice. Again, that can also assist from a cost perspective, also bringing you a faster return on investment as well. And then designed with time to market being the key objective. So this is where the whole self-service piece comes into play. Being able to consume APIs to address your workload deployments, building that automation around that, also having the automation that underpins the solution. So as you start to scale out, you want to scale that out in an automated fashion, which is something else that we'll be delving into in more detail, and Menno will be giving you examples of. Unified access, back to that sort of security piece as well, where it is controlling who can access what and having that deployed, say, in a centralized fashion. And then the standardization is also key within that I mentioned earlier. Provide the full lifecycle management. So not only is it about sort of getting you stood up, running the cloud deployed and operational, but it's also about being able to provide that lifecycle management of all the components that build up the whole solution. So not only is it just about the cloud itself, but also the accommodating piece like the storage solution, the network components, the operational insights is also key. So are you able to, say, have dashboards into the visibility of the health of your cloud, the capacity available, the utilization? That's also essential from an enterprise cloud perspective. And then back to the standardized point as well, and the automated security. So a templated, secure approach driven by automation. We've got the CI/CD piece that integrates with that to give you updates to features and functionality, and the whole DevSecOps approach in terms of us and our product engineering, as well as for yourselves as workload owners. Monitored and designed with a true granular billing system. So that's what we see as absolutely essential, not an estimated cost of the infrastructure. So this is all down to capturing the correct metrics in terms of usage on a per tenant basis, and then hosted on-premise but scale. So it can be easily upgraded to meet the growing demands without significant overhaul. And again, I can talk a little bit about the underpinnings and what facilitates that. We are an infrastructure partner, so just quickly to talk through what to expect from an infrastructure partner, where we can assist. This is all about rapid deployment. Deploy within a few days of the hardware being verified, which we'll drill into. Reducing overhead, reducing that operations overhead. Automated and integrated lifecycle management, which we've talked about. And then the workload onboarding. So we do also, whilst we can provide a solid on-premise cloud platform, we do with some of our customers work on migrating the workloads as well. How do we onboard your workload? How do we make sure you're getting the best utilization of this platform? And we have a whole professional services division that can assist with that as well. And ultimately, this is with us giving you a complete solution. Now, when I say complete solution, whilst we're talking about cloud, there is the virtualization tier within that, but also there's the containerization of applications as well. And so you want a system that can give you the ability to lifecycle manage and be able to deploy your, say, underlying containerization infrastructure, as well as accommodating your virtualization requirements. So how's that done from a Mirantis perspective? I'll just quickly talk you through some of these components, but we do have talks going into much more detail. But just to give you a brief overview, the centralized piece of our solution is this containerized piece, this container orchestrator in the middle, this Mirantis container cloud. This enables you to deploy in an automated fashion an underlying Kubernetes cluster solution, which is called Mirantis Kubernetes Engine. So what we do is we use MKE to be able to run OpenStack on, and that would address all of the virtualization requirements for an on-premise cloud. But what you can also do is run those clusters individually on OpenStack or on bare metal or on the various providers shown below to be able to address your containerization. So you have a solution here that provides the underlying automated configuration of addressing your virtualized workload through OpenStack. And you can see that we can fine tune that. We've got various customers that run different types of workloads. Some integrate with infrastructure as code. We've done a lot of work with telcos, with 5G and Edge. There can be a lot of data analytics requirements that require, say, a virtualization solution. But also on the right-hand side, you can see we can do the same from a containerized perspective as well. So we are able to address multiple use cases, be it virtualized or containerized. We talked about the operational insights. So there's the monitoring and billing piece there. The logging, monitoring, and alerting is provided by a solution that we call Stacklight. That's built by us utilizing a load of open source technologies that we've used in the past. We capture a serious amount of metrics and logs that are able to be analyzed through various components that we provide within Stacklight. But that does give you all of that insight into utilization, health, capacity, the whole logging, monitoring, alerting. It's able to we can integrate this upstream with your own monitoring systems as well that you have within your enterprise. So that's something that we do on a common basis. And then from a security piece as well, there's a secure registry solution that is also something that we can accommodate just to ensure that whatever you're deploying is secure, it's been scanned, it's been checked, you're not exposing yourself to any vulnerabilities, again, as part of the whole Mirantis solution stack. So how does this look from an on-premise cloud footprint in terms of nodes? I'll give you what we have here is the Mirantis OpenStack Kubernetes solution. So here, this is essentially our on-premise cloud footprint for addressing your virtualization requirements. Again, you can use Mirantis Container Cloud to deploy Mirantis Kubernetes engine on top of OpenStack as well. So it does address both your virtualized workload as well as your containerized application requirements. And just in terms of what is a minimum hardware setup, so what we're showing at the bottom left-hand side here is Mirantis Container Cloud, and you can see as a minimum there's 3 Mirantis Container Cloud physical nodes. These are essentially what will underpin the provisioning and lifecycle management of your Mirantis Kubernetes engine clusters. We use the cluster itself then to host the control plane. So the infrastructure node shown here, we deploy these in 3s as well. So you'll have the Kubernetes manager that's running as 3 physical nodes. Again, this is back to addressing resilience and high availability. And then from a OpenStack perspective, so running the whole logging, monitoring, and alerting solution, which is Stacklight, running the control plane that essentially is providing all of the sort of OpenStack control, the management function within there. That's deployed across 3 physical nodes. And then you can have whatever number of bare metal nodes and storage nodes that you need. So from a storage perspective, we do recommend starting with 9 physical nodes, especially from a production perspective. So we don't tend to go less than that because you don't want a node taking out the cluster or having such a negative impact. We find that at 9 nodes, the blast radius and the time to say balance the cluster itself is a lot shorter and more acceptable in terms of an enterprise grade solution. But yeah, this is showing you what is a minimal footprint. Now, Menno will go on to talk about what we've done with other customers, and what we can do is break this out. So run a larger control plane, break out certain components like network gateways, and run Stacklight on a separate subset of control plane nodes, again, just to be able to accommodate a much larger cloud footprint. But this is just to show you that we can start small and be able to scale out in an automated fashion to a much larger footprint. And now I'll hand you over to Menno, who will talk through the deployment piece.
Yes. So what does it take to deploy a large cloud, as we say, from MOSK? Basically, we have 5 phases, and per individual phase, I will talk you through what's being done to get to the end result. So we go to phase 1. This is the customer preparation phase, right? This is the responsibility of the customer. This is the racking and stacking. This is the networking. This is like getting the nodes up to latest firmwares, that kind of stuff, and then hand it over to us. So the first part is the hardware readiness in terms of racking, stacking. That's being done by the customer's data center team. Then the network readiness, that's being done by the customer network team. That's top of rack switches, that's spine switches, and all the connectivity that's related to that. Then there is a cycle of BIOS and firmware upgrades. That's done by the private cloud operations team. So the customer also has like a operations team, takes care of their clouds, right? And then they hand this over, that like completed tasks, they hand it over to the Mirantis deployment team. and that's being done by that same cloud operations team. So from there on, we go into the second phase. The second phase is actually in combo with the customer and working closely together. But first of all, any large customer, large enterprise customer would have their network very secure by firewall ruling. So we have to request, let's say, additional firewall rules for the specific deployment. That's being done by our team in combination with the private cloud operations team and the customer firewall team. Once those rules are in place, we can run our hardware checks. This is an automated Mirantis process. And so are the network checks. So once we have the handover for this private cloud operations team, we can running our automation. And this automation that pulls information over the network from all the individual nodes, those automated link checks, and gives us an output from which we can escalate to the customer, for example, by requesting the customer team to check the network, to check links, or if we need to check individual nodes on hardware issues. We do have advanced network checks. That means that if we cannot get around the first initial checks, which is just link up or link down, we have a tool that we can install on the individual nodes, and then we can work together with the customer network team, and we can identify certain traffics, certain types of traffic, and even we can go into the customer, look into the customer switch side together with the customer network team and see where the issue is. So we also have to prepare our deployment templates, right, before we start the actual deployment, and this is also an automated process by the Mirantis deployment team with our deployment automation. From there on, we will start the actual deployment, and that is phase 3. We start from the seed node, as we call it. We need to have a certain VLAN configured, for example, and then we have to upload some images there, and from there on, we can install all the other node roles. That's the actual point where we consider like the real deployment, when we push the deployment button. So then we start with, after this seed node, we continue with the MCC management cluster deployment, followed by the infrastructure cluster deployment, then the Ceph cluster, the storage cluster deployment, and then we will add all the compute nodes. After this deployment phase, then we have to go into our quality assurance, which is phase 4. First of all, this is functionality testing, for example, Tempest tests, right? Spinning up a VM, connecting a network interface, etc. We will document this process, and we will hand this over, or we will use this document as a handover document, for example, to our support organization team or the customer. Followed by performance testing, right? So we have performance tests in our quality insurance cycles. We will document this, and we will share this as well as part of our handover document artifacts. Then phase 5, which is the handover phase. This is very important. This is when we are done as the Mirantis deployment team. We will hand over this to our Mirantis OpsCare support organization. We will arrange knowledge transfers. We will discuss that with support guys and say, okay, this is what we have done for this cloud. Here is your documentation. Is there any deviations, for example? And then once that is stamped off, that is then a handover to our support organization. And we will do also a handover to the customer, which is then handed over back to this private cloud operations team, which I mentioned in the beginning of this slide. So all of this, phase 2 to 5, which is then, let's say, from where Mirantis gets involved, we can do this for you in 4 weeks, 4 working weeks.
And there's a lot of work that's gone into that and experience, right? So like we're saying, adding in the automation piece is essential throughout, even with the preparation phase, right, and the checking.
So how does a large MOSK cloud for Mirantis look like? So the current design that we have 2 types of racks. We have a controller rack and a compute rack. Both of these racks have storage nodes. And the difference is that the amount of compute nodes per rack. So the compute node rack, as you can imagine, only contains compute nodes for workloads. And then the controller rack does have a, let's say, infrastructure section, and that contains of 3 nodes of the MCC management nodes. We have 3 nodes of the MKE master nodes. We have 3 nodes of our stack-like monitoring nodes. We have 3 nodes of MOSK controller nodes, and we have 3 network gateway nodes. Why 3? That's a minimum cluster design, right? So this is totaling into 15 infrastructure nodes. Total of storage nodes, that will be 48 nodes, 2 per each rack type. We have a total of 441 compute nodes, which gives us a total of 504 divided on 24 racks, and we have 3 controller racks, and we have 19 compute racks. As I mentioned, this is the current design, and we are also working with our developers to increase this number. Next slide.
Yeah, just to add to that, yeah. So like you said, right, this is a great example of where we've got up to 500 nodes plus, but we are in the process of looking at building out a larger footprint than this. But just a quick point to make regarding the infrastructure nodes. This is where I did show you initially that there were the 3 for the minimum viable footprint, but we've broken those out here. So if you look at stack, like the actual logging, monitoring, and alerting, we've broken that out for this size of cloud, as well as for the control plane nodes themselves separate, and also separated out the network gateway nodes. So we do have the ability to sort of take the control plane apart and spread components across different nodes to accommodate a certain size and footprint of cloud.
Yeah, so something interesting that we have is like the availability zones, right? So this is for the compute racks. So we have 3 availability zones, and this will allow for full HA by replicating the instances with 3 replicas within the 3 availability zones. All right, so this is our customer example. We added this just to show a little bit more of details around large deployments that we were doing for our customers. So one of our customers asked us to deploy over 6,000 nodes. With the current design, we split that up in 13 different individual environments. So if we look at the infrastructure nodes, that's the same for every environment. We have 15 of them. Storage nodes, that's usually 48, but there is some larger and smaller clouds even in this design, let's say, from the customer at customer request. So let's say on average, it will be 48 storage nodes. And on average, we will have 441 compute nodes. And then the total per cloud would be on average like 400 and 504. And then you have a number of how many nodes were we able to deploy, and then how many nodes were we not able to deploy. And this is important to talk about the challenges and the improvements that we were able to get out of it. So yeah, over 6,000 nodes deployed for this specific customer, which is a nice number to talk about, right?
Yeah, and with this specific customer, these are all geographically distributed as well. Certain clouds are within a environment, within ADC, and then you've got multiple data centers within different geographical locations. So we've also worked towards how can we accommodate this from a workload perspective? How do you utilize which cloud for certain types of hardware, or do we have a general use case scenario? So there's layers above this that we start to sort of work out as to where to best place workload, how to utilize the APIs, how do we start to aggregate, at which point do we aggregate? So those are also sort of key factors when you start to go at a multi-cloud, multi-regional, multi-geographical level as well.
Okay, so from the same customer example, this slide just shows when we started with this customer, we started with X amount of days of rollout, and then over time, we could see the improvements that we have been put in place by either working with the customer or improving our code, for example, or becoming more efficient. So I'll give you a few examples. So in red, it would be blockers, right, for a deployment. In blue, it will be, let's say, everything within Mirantis control. and green, that's the quality assurance. So on top, you can see in green, our quality assurance is quite consistent. And in blue, there have been some variations, let's say, in deployment times. This could be, for example, due to some bugs. Yeah, so we utilize upstream components, and sometimes out of our control, there is a bug that needs to be fixed, and our developers do a very great job in doing that, and have been doing that, and have been improving, let's say, all the components that we are using in our deployments. So eventually, let's say the end result, this MOSK environment 13 that I mentioned, we ended up in deploying, doing the actual deployment, let's say from seed node to adding all the compute nodes in 7 days. Quality assurance was 5 days, and then we were blocked for 4 days. So yeah, just illustrating the improvements that we have been making over time.
Yeah, and like you're saying, like sometimes bugs are just inevitable, but it is about us addressing those, passing those on to our customers, as well as providing that upstream. And that's I think where we've seen with people that, or customers that have come with a sort of DIY environment, that they've struggled with things like that. So also that's something that we're very familiar with, have worked with, and able to contribute back, as well as pass that on to our customers. But yeah, this is a great example of showing how we've worked to refine the whole process as well.
Right. So, for example, challenges that we encountered on the left column. First of all, the firewall requests for these specific deployments. So what we've done is to standardize this firewall process and work very closely with this private cloud operations team, which for that specific customer. And what it did is reduced our time to start the deployments, but also some firewall rules, for example, were needed for some QA cycles. And then the whole standardization resulted in reduced lead time and QA cycle time. The next issue, this is actually very important for us, because we are on the infrastructure level, we are on the hardware level, right? So all the nodes, they need to be cabled up. And if you have a 6,000 node fleet, right, then, and 4 nodes per cable, you have over 24,000 cables. So you can imagine that if you ask customer data center team for every single cable issue, go to the data center and check it, and people that have data center experience can imagine that is going to be very, very inefficient and costly, and also very impractical. So what we have put in place for that specific challenge is that we work very closely with the customer's data center team, and we have this automated pre-deployment cable link checks. So before we press the actual deployment button, we can run this automated link checks that will show up from every node, what if the cable is if the links are up or down, and then we can just, let's say, create one big escalation for all the links at the same time, instead of like individual escalations to the customer. So that resulted in a reduction of start-stop deployment scenario. For example, if we would not have this automated pre-deployment cabling checks, we would start deployment, and then we run into a cable issue. We have to stop. It needs to be fixed, and then again and again and again and again. So we have been able to reduce that start-stop deployment scenario, and also reducing the tickets to the data center cabling team. And what I mean is that, like, instead of like all these many individual tickets, we can just, before we start deploying, we escalate one, let's say, accumulated version of what we see, and they look into that and they fix it for us in one go. The other challenge that we had is, like, obviously hardware issues, right? As I mentioned, there's a lot of hardware involved. So we have automated pre-deployment hardware checks, and this resulted into nodes that cannot be deployed. For example, we can detect if there's a power supply failure, if there is a motherboard failure. Yeah, we can detect this in our automated pre-deployment hardware checks, and then those nodes can be excluded, for example, and they can be fixed and added later. again, reducing the start-stop deployment scenario as well. Network configuration issues. So we have automated pre-deployment network link checks, as I mentioned. So for cable checks, but this extends into switch port, let's say switch port statuses that we can ask from the customer network team. And also we can install a pre-deployment network diagnostics tool, in which we can generate, for example, LLDP traffic, and we can op network bonds. And this is before we install the actual operating system. So this is a tiny diagnostic tool which allows us to do this. And this also reduces our start-stop deployment scenarios, and it also reduces the nodes that cannot be deployed. And as lastly, the challenges that we have seen with our MOSK software issues, for example, MCC bug that resulted in slow node deployment rates. So as I mentioned, our developers have done a great job in fixing those kind of bugs. And also we have increased the bare metal deployment velocity. When we started these rollouts, we started with batches of 6 nodes. And now for production nodes, we are able to do 50 node batches in one go. And this reduces the overall deployment rollout timelines, right? So that's what I mentioned. Like, let's say we can do the whole deployment now, including all these improvements, like within 4 weeks.
Okay, right. So just to summarize, in terms of planning and the points that I was talking about, the technology imperatives, there's all the considerations that I mentioned, the design principles that to adhere to. So considerations around the hardware, the configuration, what's the workload requirements, design principles, standardization, automation, wherever you can, looking at that. Talks about our approach. Again, you can go onto our website. You can look at docs.mirantis.com for something that's much more detailed, like architecture guides, deployment guides, operations guides, but talks about the components that we utilize within our solution stack for that. What would you look for ideally from a cloud infrastructure partner? Touched upon that in terms of the rapid deployment, how we can assist. We can also assist with workload onboarding. We can make sure that we've right-sized your environment, which is absolutely key and crucial to a success. And then the key infrastructure components, so the different deployment models that we can address, the workload that we can address, the containerization piece, the virtualized workload, the logging, monitoring, and alerting, the secure registry component as well if needed. And also all about managing resource allocation. So how do we dissect the cloud? How do we give you the correct underlying hardware configurations for your different types of workload? And also importantly, how do we scale with that through the automation that we can provide, along with, say, bundling in certain profiles, certain configurations. And then the automation and orchestration, which I've talked about, which is essential to underpinning that, and also giving us these much tighter deployment timescales and timeframes as well. So our software components drive that, enable that automation, enable the orchestration also from a workload perspective to integrate with and drive the deployment and lifecycle management of certain components. So that's also key within our, say, key infrastructure components that we talked about. And then Menno, I'll hand over to you for the deployment key points.
Yeah, so the increased deployment efficiency and process and workflows over time through experience, that's one. The advanced deployment automation, that's the second one. And advanced network diagnostic tooling, that's the third one. And bug fixing in MCC and removing all resource limitations, that's the fourth one, and that's including that node batch deployment velocity.
Yeah, that's essentially how we bring it all together. That's the end of us talking. Thank you for your time and attending this talk. And if there is anything further you need, you'll see on the Bright Talk link that you can access our contact details. So please don't hesitate to give me a ping, or also you can get in touch with us via the website, whatever works for yourselves. If there's anything further you want to dig into or drill, please don't hesitate to contact us. But thank you for your time.